Hello everyone, myself Shashwat and I am the lead for Team Maverick. And today I am here to highlight a growing crisis that needs an urgent attention, a problem where current solutions are not enough and lives are at risk. In times of emergency, every second counts, whether it's a medical crisis or a search and rescue mission in challenging terrains. Delays can be the difference between life and death. India, with its vast geography and growing population, faces critical issues. Medical emergencies often face delays due to traffic or distance. Search and rescue operations in difficult terrains or poor visibility conditions are frequently hindered, delaying vital rescue efforts. And even if victims are located, guiding them to safety becomes a challenge. But what if we could change that?
Imagine an autonomous drone bypassing traffic, flying over geographic obstacles, and delivering medical aid directly to those in need. Drones equipped with thermal cameras and AI driven pathfinding algorithms, guiding rescue teams in real time, detecting survivors even in low visibility conditions. With AI optimized rescue routes, civilians could be guided to safety faster and more efficiently.
And hence, for bringing this imagination to reality, Team Maverick is presenting the game changing solution LifelineX. So, let's break it down into three core steps. First, using machine learning, we will train drones to navigate autonomously through complex terrains and obstacles in real time. Equipped with GPS, they report the exact position of survivors, cutting down on the time it takes for the rescue team to reach them.
Next, with convolutional neural networks or CNNs, our drone will analyze live video feeds from cameras combined with sensor data. By employing recurrent neural networks, we track movement patterns over time, identifying survivors even in the most challenging conditions. Finally, by analyzing maps, satellite imagery, and terrain, our algorithms like Dijkstra's algorithm find the most efficient and safest paths, ensuring rescue teams reach survivors swiftly and safely.
So, talking about technology stack behind this innovative approach, we will be using Python, C, C++, and libraries like TensorFlow for programming and OpenCV for image processing. Our drones will be powered by Raspberry Pi and NVIDIA Jetson for real-time computation. We will also integrate cloud platforms like AWS for data handling, API of Google Maps, and design using Autodesk Fusion 360.
LifelineX is an autonomous drone designed for emergency and disaster response. The mission starts by inputting coordinates to activate the drone, which then uses cameras and sensors to scan the area. Thermal cameras capture data that is processed by an AI system to detect civilians. If no civilians are found, the drone continues scanning. Upon detecting civilians, it analyzes the surrounding terrain to determine if it can land and if rescue teams can access the location. If landing is possible, the drone computes the safest route using real-time object evidence and delivers medical kits, foods, and water for immediate aid. It also guides civilians to the safest zones by generating pathfinding routes using GPS and real-time maps. Once civilians are in these safe zones, LifelineX collects and transmits geospatial data to the control center to assist rescue teams. If landing is not feasible, LifelineX airdrops supplies in bulk to sustain civilians for a few days, ensuring they have essential resources until help arrives.
Now, let's focus on the feasibility of LifelineX. Our drone's modular design supports adaptable payloads and radio frequency-based telemetry, enhancing flexibility. We have integrated reliable UAV components such as GNSS, MEMS-based IMUs, LiDAR, and ESC motor systems, ensuring seamless integration and robust performance. To enhance automation, we are leveraging open-source platforms like PX4 and Arduino Pilot for waypoint algorithms, Kalman filters for sensor fusion, and real-time telemetry via MAV links.
Two key challenges: achieving a strong yet lightweight structure and optimizing face and object recognition. So we are solving these by using carbon fiber for structural strength and modules like OpenCV and convolutional neural network for advanced recognition and movement analysis. This robust design ensures that LifelineX is not only feasible but also highly viable for emergency response and disaster management.
Let me walk you through the key impacts and benefits of LifelineX. Autonomous medical aid. LifelineX uses GPS and IMUs to ensure precise delivery of medical supplies like AEDs in disaster zones, reducing response times and saving lives.
AI-driven pathfinding for civilian evacuation. Through machine learning, LifelineX autonomously analyzes data from LiDAR and multispectral sensors to map safe evacuation routes, optimizing paths to ensure efficient civilian rescue.
Real-time geospatial data transmission. Equipped with high-resolution cameras and sensors, LifelineX transmits live geospatial and meteorological data to emergency teams, helping them make better informed decisions in real time.
Reduce human exposure to risk. Using SLAM and obstacle avoidance, LifelineX navigates hazardous environment without putting rescue personnel at risk, making operations safer for everyone involved. These features make LifelineX a game changer in disaster management, enhancing both speed and safety in emergency situations.
In this section, we highlight the key research and reference that forms the foundation of LifelineX technology and capabilities. We start with reference on autonomous flight and mapping. This includes, firstly, the smart search system of autonomous UAVs for disaster rescue, focusing on how UAVs assist in search and rescue operations. Secondly, a study on aerial and ground robot collaborations that explores mapping in rescue missions. Next, we discuss AI-driven technologies in emergency response. A comprehensive review that reveals how AI and machine learning can enhance the efficiency of rescue operations, improving real-time decision-making in critical situations. We also draw from research on autonomous drone navigation in high-risk environments, showing how drones navigate complex terrains and reduce response time, a crucial factor in disaster scenarios.
Additionally, we include real-life case studies such as Japan Noto earthquakes, Turkey earthquakes, and the tornado damage assessment in Alabama, which demonstrate the success of drones in emergency operations. This body of research solidifies the potential of LifelineX to be a transformative tool in modern rescue missions. In conclusion, we, Team Maverick, truly believe that our project has the potential to make a real impact in terms of saving lives and providing hope in the most critical situations. Thank you for your time, and we look forward to contributing to a safer, more resilient future. Thank you, Team Maverick.